Okay, so we have talked about characteristics of life and what it is to practice science, what makes something a scientific endeavor. But now let's look at some details. In particular, we're going to talk about some chemistry. So if you look at this image that was from the first chapter, you see that we have these levels of organization, living things. And of course, living things have some chemistry going on inside them, both at the subatomic and atomic level. And that's kind of what we're going to focus on now. And then later we'll get into molecules and then some of these macromolecules. But for now, just some basic chemistry. So here's our periodic table of the elements, which you've probably seen before and studied a little bit. You will study it in great detail next year in chemistry. We're going to focus on particular elements this year. And so as we know, elements are the basic building blocks of matter. And so we want to understand a little bit about the atoms that comprise these different elements and matter. Now, with living things, there's a subset of these elements that we need to concern with, and these are sort of the main ones. We're not going to worry about silicon, but we're going to focus on what we designate as SNOPs. And so carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. You can see that in particular carbon, hydrogen, oxygen, and nitrogen are the main elements you see in living things, particularly oxygen. Think about why it is that by weight most things consist of oxygen. Why is that? Now, I'm sure you've probably studied subatomic structure a little bit in the past, but a little refresher here. Of course, you got your protons, your neutrons, and your electrons. And the protons and neutrons, as you know, are in the nucleus, and the electrons are in orbits surrounding the nucleus, as shown in this nifty image here. And so which of these three is it that sort of determines the type of element that you have? Well, perhaps you remember it's the number of protons, and so what we see is the atomic number here, 1 for hydrogen, 6 for carbon, 7 for nitrogen, etc. That's the atomic number, the number of protons. And so here's a little closer look at nitrogen. Again, we've got an atomic number of 7, so that's the number of protons. But as you may recall, in your typical atom, what about the number of protons and neutrons? What's the relationship between them? Well, they're typically the same. And so that gives us what we call the mass number, which is equal to the number of protons and neutrons, which for nitrogen would be 14, 7 protons and 7 neutrons. Now, what we have here is called the atomic mass, which is the actual weight or mass of nitrogen atoms. And you notice it's slightly more than 14. Why is that? Well, we'll get to that in a minute. Now, what about number of electrons? Well, typically in an atom, the number of protons is equal to the number of neutrons, which is equal to the number of electrons. So in nitrogen, there would typically be 7 electrons. And in again, there would be 6 protons, 6 neutrons, 6 electrons, oxygen 8, 8, and 8. But again, notice that the atomic mass is always not quite exactly the number of protons plus neutrons. Okay. So now, if we're going to draw atoms, we have what we call the Bohr model. And the Bohr model generally looks like this. You've got the nucleus, the center of the atom, and you can label it a couple different ways. You can just say, for example, it's hydrogen, or you can label it as in hydrogen has 1 proton. And then you're going to have that orbital with what? How many electrons would hydrogen have? It should have just 1. And there's our orbital with our 1 electron. Now notice that hydrogen has an atomic mass of approximately 1. Well, why is that? Well, hydrogen actually does not have any neutrons. It just has a proton and a single electron. It's a small, relatively light atom. Whereas sodium, let's see, sodium, so our nucleus, again with what we would have 11 protons and 11 neutrons. Okay. And we should have 11 electrons. Oh, what have I forgotten here? The plus and the minus. What does that represent? You can probably imagine that's the charge of these particles. Protons are positive, electrons are negative, and what? Neutrons are neutral. They have no charge, conveniently enough. Okay, so, here's our sodium. Now it's got 11 electrons. That inner orbital will have 2 electrons, so there they are. Okay. The next orbital can have as many as 8. Alright, so let's draw them. 1, 2, 3, 4, 5, 6, 7, 8. And so that gives us 8 plus 2 is 10. Ooh, we still need 1 more electron. So there's a third orbital with 1 lonely little electron out there. And so that gives us our 11. That would be our, again, our Bohr model for sodium. And so here they are again for hydrogen. There's our single little electron, 1 proton. Carbon with 6 protons, 6 neutrons for a mass number of 12. And 1, 2, 3, 4, 5, 6 electrons. Notice 2 in the inner orbital and 4 in the outer orbital. Alright, so now we'll see when we talk about this some more that the number of electrons is extremely important, particularly in that outer orbital, or what are called the valence electrons. Those are the ones in the outer orbital. And the number of valence electrons is extremely important for how that atom reacts, as we'll see, and perhaps you may recall. Okay, so now we talked about, or we wondered why the atomic mass is slightly different from the mass number. Well, why is that? Perhaps you have heard of these before. So let's see. Here's some, what do we have? We have 6 protons, so this must be what? Carbon, of course. And, okay, here it is. It has 6 neutrons, 6 protons, 6 neutrons, 6 electrons. But, ooh, what do we have here? This is still carbon. But, ooh, it has 7 neutrons, and this one has, okay, come back, 8 neutrons. What's the deal there? So these are all 3 of these are still carbon. But what are these guys? Well, all of them for that matter. So they have different numbers of neutrons. Alright, so when you have elements that are the same, or atoms that are the same element, but they have different versions, that is, different ones with different number of neutrons, do you recall that these things, what are they called? They're called isotopes. Isotopes. And so this isotope has 1 extra neutron, and this one has 2. And so these atoms are literally heavier than our typical type of carbon. Now, when you look out there in the world, most of the carbon is like this. It's what we would call C12. But there's also C13 and C14 in relatively small amounts. Again, those heavy isotopes, we call those two. So that is why carbon, when we look at all the carbon atoms out there in the world, the universe, wherever, most of them are C12, but because there are a few C13s and 14s, the mass of all of them sort of averaged together comes to slightly more than 12. So if we were to count them all, the 12s plus the 13s plus the 14s, and take an average, it would be slightly more than 12 because of those heavy isotopes. Okay, we'll talk a little more about isotopes and how they're interesting. Okay, sorry this video was a little long. A lot to cover here. Thanks.